Okay, today we're talking about cylinders, spheres, and composites. So let's look at our formulas for cylinders. And these are all found on your geometry formula chart. And so the formula for the surface area of a cylinder is 2 pi r squared plus 2 pi rh. So we have the formula and we can use it, but it's good to understand where that formula comes from. Pi r squared we know is area of a circle, and it says there are two of them because those are our bases. If we look at our cylinder, the bases are circles. So that's really just 2 times the area of the base like we were used to from prisms. And then we have 2 pi rh. Well, we all know that the circumference of a circle is pi times diameter, or 2 pi r. So that's the circumference of a circle. That's the circumference of a circle times the height, And if you think about it, why did they do the circumference of the circle? Because that's like the perimeter of the shape, okay? We don't call it perimeter when it's on a circle. We call it circumference, but it's like the perimeter of the base times height, okay? Which gives you your lateral surface area like we were used to in prisms from yesterday. So it's the same idea, but using slightly different language for a circular base. And so those are have a special name, and they're known as cylinders. So that's just a prism with a circular base. And we think of it as a prism because it's the same shape all the way up. And so the circular bases, and it's a circle all the way up. Okay, and what about the formula for volume of a cylinder? Well, according to our formula chart, it's pi r squared h. And so if we think about why that's our formula, remember we said that pi r squared is just the area of a circle. So that's just area of the base times height. It's just area of the base times height, which should sound familiar with the other formulas that we've learned. So let's try using them. Okay, in this first example, it wants the surface area and volume. Surface area, using our formula, is 2 pi r squared plus 2 pi rh. And I like to write my formulas out before I plug into them. So that's going to be 2 pi times my radius squared plus 2 pi times my radius times height. Okay, so when I go find my radius, there it is in my picture. The radius is 11. So I'll drop that in both places that I need my radius. And the height is 26. So I'll plug that in where I need the height. And then we just put that in our calculator, and we get that the surface area is 2,557.26 square yards. Now we're going to go to 2 decimal places in all of our notes today. So that's just what we'll be looking for. So surface area is 2,557.26 square yards. How did I get that? I just plugged it into my calculator. For time's sake, I'm not going to show that during the video notes, but if you need help with the calculator, just let your teachers know. We're happy to help you with that during class. Okay, now the formula for volume is pi r squared h. So it's going to be pi times our radius squared times our height. Okay, we said our radius is 11. We said our height is 26. And when we put that in our calculator, we get that the volume of the cylinder is 9,883.45 cubic yards. Now, remember, volume is in 3 dimensions, and so it's going to be cubic yards, whereas area is in 2 dimensions, and so it's going to be square yards. Okay, let's try that again. For our next one, it's the same formulas. Volume is pi r squared h. And so I'm going to set it up pi times my radius squared times my height. Now, when I go to label it, I notice a couple of things. My cylinder is turned on its side. I say it's on its side because it's not standing on its base. Remember, it's got a circular base and then it's the same shape all the way up. So it's got a circular base there, and it has a circular base there, and it's the same shape all the way up. So it's turned on its side, but that still means that it's got that circular base. But what that means for us is that this 9 here is actually the height of the cylinder. It's the height of the cylinder. And when I'm looking for the radius, they didn't give me the radius this time. They gave me the diameter. That goes all the way across the circle, so that's a diameter. So that's a diameter, but that's no problem. I can use it to find the radius. If the diameter is 15, we know that the radius is just half the diameter, so half of 15. So that's just 7.5. So now that I have my radius, I can plug it in. It's going to be 7.5. And my height, we said, was 9. And I'll put that in my calculator, and we get that the volume is approximately 1,590.43 meters are our units, and we're going to say cubic meters because volume is in 3 dimensions. So that's going to be cubic meters. Let's try surface area again for good practice. So the surface area of a cylinder, looking at your formula chart, we said that it's 2 pi r squared plus 2 pi rh. So it's going to be 2 pi, I put a parentheses for my radius squared, plus 2 pi, parentheses for my radius, and a parentheses for my height. So dropping those in, we said that our radius is 7.5. And we said that our height is 9. And when I put that in my calculator, I get that the surface area is 777.54 square meters. Why is it square meters and not cubic meters? Because this is surface area, and area covers 2 dimensions, so it's square units. Okay, so that's going to be cylinders. Let's take a look at spheres. So again, this is on your formula chart. We have that the surface area of a sphere is 4 pi r squared. And the volume of a sphere is 4/3 pi r cubed. And I just pulled those straight from my formula chart. So let's use those. Okay, when I want to find the surface area, it's going to be 4 pi times my radius squared. I can see here from my diagram, the radius, which comes from the center to the edge of the sphere, is 2.8, so that's my radius. So I'll drop that in, plug it into my calculator, and I get that the surface area is approximately 98.52 meters squared. Again, area will be square units. Okay, so what about volume? Let's give that formula a try. So volume equals 4/3 pi r cubed. So that's going to be 4/3 pi times my radius cubed. We said we know our radius is 2.8. And let's go ahead and look at that one on the calculator just for a little practice with a fraction and pi. So let's take a look at that. So that's going to be 4 divided by 3 is 4/3. Scroll out of the fraction. Our pi button is here at the bottom. Pi. My radius is 2.8. Not sure why that's popping up while I'm doing video notes. It's a good thing we're not doing all of these on the calculator. Then I'm going to do my little a to a power button here, and we're going to put in an exponent. So I didn't do the squared button because I don't want it squared, I want it cubed. And when it says a to the b, that's putting a variable in there, and you can put in any power you want. We want it to be cubed, so I'll put in 3. And I get 91.95 if we're rounding to 2 decimal places. So that volume is approximately, again, the wavy equal sign means approximately 91.95 cubic meters because volume is in 3 dimensions. Okay, so let's try hemispheres. Hemispheres are not on your formula card, but since spheres are, and hemispheres are just half of a sphere, remember hemi means half, okay? So then we're just going to be able to use those sphere formulas to figure out the volume and surface area of a hemisphere. Now, if I started by just doing half of a sphere, that would give me 2 pi r squared, okay? So half of a sphere would give me 2 pi r squared. But that wouldn't be all of my surface area because when you slice it open, you pick up this new surface that's not part of the regular sphere. You pick up the surface of this circle right here. So when we did just the hemisphere, we were getting that circular surface area that goes in 3 dimensions there. Okay. And so now we need to also pick up that flat circle on the surface. So we know the area of a circle is pi r squared, so we need to add another pi r squared to that. So what's 2 pi r squareds plus another pi r squared? It's our formula for surface area, which is 3 pi r squared. Okay, that gives us 3 pi r squared for the surface area. Now the volume's a little bit easier. We want half the volume of the sphere. So if we do half times 4/3 pi r cubed, if I simplify before I multiply, that 2 on bottom goes into the 4 on top 2 times, and that leaves me 2/3 pi r cubed. That's going to be 2/3 pi r cubed for our formula for volume. So let's go use those new formulas. Okay, so we want to try surface area and volume. So our surface area is going to be 3 pi r squared. Again, this time they gave us a diameter. So if that's the diameter, can you tell me what the radius would be? You betcha. So if the diameter is 18, then my radius is just half of that, or 9 feet is my radius. Okay. So when we're plugging into the formula, surface area is 3 pi times my radius squared. We said our radius is 9. And when I put that in the calculator, I get that my surface area is approximately 763.41, and that's going to be square feet. Okay, let's try our volume formula. We said volume is 2/3 pi r cubed. So plugging into that formula, that's going to be 2/3 pi times our radius cubed. We said our radius was 9 feet. So when I put that in my calculator, I'll get that my volume is approximately 1,526.81 cubic feet. So that's feet cubed. Remember, volume's in 3 dimensions, so that's going to be cubic feet. Okay, so that's 2 of our shapes for today, cylinders and spheres. Picked up a bonus there with hemispheres. But let's take a look now at composites. Composites are when we put 2 or more shapes together, or we have shapes within a shape. Okay, and so those are going to be our composites. The important thing to know about composites is that finding composite surface area and volume means you may have to, and we've left the blanks here for you to fill it in, to remember you may have to add or subtract certain parts or figures, Okay, so let's take a look at that. So this first page is just regular area, not surface area or volume, just regular area. And we want to find the total surface area. So if I look at it, I can see that this shape is made up of a triangle and a rectangle. In fact, it looks like it's a square. Okay, so we have those two shapes added together. So to find the total area, I'm just going to find the area of the triangle, and I'm going to add the area of the square or the rectangle. Squares are rectangles, so we can think of it that way. Okay, so let's do this. When I want the area of a triangle, I know the formula for area of a triangle is 1/2 base times height. And that's on your formula card as well. Okay, so looking to plug into that, I've got 1/2. The base of the triangle, can you see it? This 24 here on the bottom means the side across from it is also 24 because opposite sides are congruent in a parallelogram. We have these right angles and those congruent sides. So we know those are all four the same. So I know the base of that triangle, plugging that in, is going to be 24 times the height of that triangle is actually given. Do you see it? There's that little arrow pointing to it. That 35 is this height of the triangle right here. Okay, that's pointing to that height of the triangle right there. So we'll drop in our 35. When I put that in my calculator, I get that the area of the triangle is 420 inches squared. Okay, so let's find the area of our rectangle. Okay, now remember, squares are rectangles. Our formula for area of a rectangle is length times width. Now, what am I drawing there? When I did the, I'm just doing a subscript with a shape drawn in there to help me know which area I'm talking about because we have lots of areas in this problem. So that's just going to be length times width. Because this is a square, these sides are marked congruent. Those are both 24. So when I plug 24 in for both of those and put that in the calculator, I get that the area of my square is 576 square inches or inches squared. Okay, so our plan was to get the total area. So we said the total area, and so I'm going to use capital A with no subscript there, just talking about the whole area, is going to be the area of my triangle plus the area of my rectangle. So area of my triangle was 420 square inches. Area of my rectangle is 576 square inches. So that gives me a total area of 996 square inches. Very nice. So, okay, and then we want to find on the next one, it asks us to find the area of the shaded region. Now, so we added to get that total area of those two composite shapes together. And now to get the area of just the shaded region, we're going to have to subtract. And that's what we said. Sometimes we'll have to add and sometimes we'll have to subtract. So my plan to get just the shaded region, what I'm going to do this time is I'm going to take the area of the rectangle and I'm going to subtract the area of the triangle. It's going to be area of the rectangle minus area of the triangle. That's my strategy to get the area of the shaded region, just the shaded part. Okay, so let's give that a try. For area of the rectangle, we know that that's just length times width. Again, that's on our formula chart. So our length there, I usually call the longer one the length, so that's going to be 25 times our width then would be 14. Just pulling that out, this is my length, this is my width. And so when I put that in my triangle, I get that the area of the rectangle is 350 square centimeters. Okay, so we need the area of that triangle. We also know the formula for area of a triangle. It's just 1/2 base times height. That's on your formula card. The base of that triangle is just the other side of the rectangle. So if this side is 25, we know this side is 25 because opposite sides are congruent for rectangles. So I'll plug 25 in for the base of the triangle. The height of the triangle is given to us. That's this right here. So that's 11 centimeters. So I'll drop in the 11 for that. And when I put that in my triangle, in my calculator rather, I get that the area of the triangle is 137.5 centimeters squared. Aren't we thankful for calculators? They really make our life easier. So when I want the area of the shaded part, what was our big plan there? Our plan was to find area of the shaded. So I'm going to use a subscript of S for shaded. Okay, is going to be area of the rectangle minus area of the triangle. So area of the rectangle was 350. Area of the triangle was 137.5. Oops, let's change colors to keep that coordinated so we can tell where those numbers came from. 137.5 was the area of the triangle that we're subtracting. And that gives me an area of the shaded region that equals 212.5 centimeters. 212.5 centimeters squared. Okay, so when we have a composite shape, you have to add or subtract different parts to get the part you're looking for. So it takes a little problem solving at the beginning to make sure that you're picking the correct shapes and the correct strategy. Let's take it up now a notch now and try surface area and volume with composites. Okay, so our last two examples ask us to find surface area and volume. This first one is just the total surface area for this shape. So let's look at what the shape is so we can put our plan together. Okay, so the total surface area is going to be, taking a look at this, look, what do we have here? What's going on? If I take a look, I can see I've got a triangular prism here, and I know it's a triangular prism because both bases are a triangle. Okay, it's just laying on its side. Both bases are a triangle, and then it's the same shape all the way up. Okay, it's just laying on its side, so same shape all the way up. So I've got a triangular prism there, and that's laying on top of I have a rectangular prism on the bottom. So I have a rectangular prism on the bottom. And again, that's a rectangular prism because both bases are a rectangle. And then it's that same shape all the way up. Okay. So we're looking for surface area here. Remember, surface area is the area on the surface or on the outside of the figure. So if I think about it, if I'm just looking at the outside of this, I'm not going to have the total surface area of that triangular prism on top because one side of it is laying, this side of it is laying on top of the rectangular prism. So I'm going to have to subtract out that side of the rectangular of the triangular prism. Okay, so my only parts of this triangular prism that are included, it's going to be the surface area of the triangular prism minus that one side, which is a rectangle. Okay, then I'm going to add to that the surface area of the rectangular prism. Do we have all the surfaces of the rectangular prism? We do not, because that one side of the rectangular prism is covered up with the side of the triangular prism. So I'll have to subtract that one rectangular side from the surface area of that prism. So that's our plan. Triangular prism surface area minus one rectangle plus rectangular prism surface area minus one rectangle. So let's see if we can get started finding those things. So for the triangular prism, we need the surface area. So surface area of a triangular prism, you've got your formula chart handy. You can see it's the height of the prism times the perimeter plus 2 times the area of the base. So let's think about this. The height of that triangular prism, it's laying on its side, so that height is 15 units long. That's the height of the triangular prism. Now, the perimeter of the prism, remember, that's the perimeter of the base. And if I look at this triangle, two sides are 9 units long, and actually all three sides are. When I checked the bottom underneath, we can see that that's 9 units also. So we had 9 on that side, 9 on that side, and 9 on that shape on the bottom. So that perimeter is just going to be 9 times 9, 9 plus 9 plus 9, add up all three sides, 9 plus 9 plus 9, or 3 times 9 if you will. And that perimeter of the base of the triangular prism is 27 units. Okay, so we need the area of that base. We need the area of the base. And that's the base is a triangle. So the formula for the area of a triangle is 1/2 base times height. Okay, so it's easy to get the base of that triangle. We already know that it's 9 units. But what about the height of that triangle? Let's take a look there. What about that height of that triangle? We know the base is 9 units, but what about the height? Well, over here they told us that the height of the entire composite figure is 19.8. And here we see that the height of this part is 12. So if we do 19.8 minus the 12, which is the height of the rectangular prism, that leaves 7.8 for the height of the triangular prism. So that's going to be 7.8 for the height of our triangle. And I should say that's the height of the triangle because we're calling the height of the whole prism that long area of 15. Okay, so if I plug that into my calculator, I get that the area of the base is 35.1. Okay, so now we've got everything we need to find the surface area of that triangular prism. So let's do that. So the surface area of the triangular prism is going to be height of the prism times perimeter plus 2 times area of the base. And we just found all of those parts, so let's plug them in. We said the height of the prism was 15. We said the perimeter of the base is 27 because it's a triangular base, so the perimeter of that triangle is the perimeter of the base. And then 2 times the area of the base, so 2 times the area of that triangular base, we said was 35.1. When I put that in my calculator, I get that the surface area of the triangular prism is 475.2 units. And that our units are in feet, so I'll call that square feet. Okay, that's area, so it's square feet. And it turns out that that's the exact value of that, so I'm going to erase my approximate sign and keep that an equal sign because it is exactly equal to that. Okay, so now the next shape that we need to find, we just found the area of the surface area of the triangular prism. We need to find the area of that rectangle that they had in common. So let's do that rectangle next. So I'm color coding and I'm labeling everything so I can follow my work and check it if I make a mistake. So my area of a rectangle, I know, is just length times width. Length times width. So if I look at that rectangle, it has a length of 15. Here's 15. And it's got a width of 9 feet, just like this 9 feet down there. So it's got a width of 9. So 15 times 9 is 135. And so that's an area of 135 square feet for the rectangle. Whew, finally one that was easy. Okay, so let's go work on the surface area of that rectangular prism. Let's do the surface area of the rectangular prism next. So I'm just breaking this down part by part, not letting it stress me out. Surface area of a rectangular prism. The formula on our formula chart tells us that the surface area is 2 times the length times the width plus 2 times the length times the height. And that's a cursive L, by the way, if you're wondering. plus 2 times the width times the height. Okay, so I'm going to extend my page a little bit so we can have some more room to work. Okay, so plugging into that formula, that's going to be 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. Okay, so let's go look at our rectangular prism. Now we already called the length and width, the length 15. So I already called that the length and 9 the width when I was working on the area of that rectangle. So I'm going to call the 12 my height. Okay, so we want to label them so that we make sure we only plug them in the right place. So when I'm plugging in the length, that 15 is going to go in 2 different places. When I'm plugging in the width, that 9 is going to go in 2 different places. And then when I'm plugging in the height, that 12 is going to go in 2 different places. Then I put that all in my calculator, and I get that the surface area of the rectangular prism equals 846 square feet. Okay, so we found the surface area of the rectangular prism. We already know the surface area of the rectangle. Okay, we found it here before, so we already have that. So we're ready to put it all together. So let's see if we can follow that plan to do that. Okay, so our plan for the total surface area is going to equal the triangular prism surface area, which is 475.2, minus the rectangle, which was 135, plus the surface area of the rectangular prism, which was 846. And I'm just getting this from right here above where I have my plan worked out, okay? Minus the rectangle that they have in common. So minus that 135 again. And when I put that in my calculator, I get that the total surface area is 1,051.2 square feet. Remember, you can pause the video to double check any of these parts. Make sure that that's making sense to you, that you get the same numbers when you plug it in the calculator. And we're almost finished. One more. We've got to find the total volume of this composite figure. So we did surface area on one, and now we're going to do volume on another. Now notice that this is a triangular prism, but in that triangular prism, there is a cylinder that has been drilled out of it or cut out of it. So you can see we've got a circular prism, or cylinder rather, because we call circular prisms cylinders. So we've got a cylinder that's been drilled out of that triangular prism. So that's a triangular prism because both bases are triangles and it's that same shape all the way up. That's what makes it a triangular prism. Okay, so we've got that triangular bases and it's that same shape all the way up. But we do have that cylinder that's drilled out of it. Okay, so it's that same shape all the way up. Okay, now it says here there's a little note and it got cut off a little bit on this page. It says the cylinder radius is 1. The cylinder radius equals 1. So I'll just rewrite that there for us. We'll need that in a bit. First thing we want to do is come up with a plan so we know how we're going to approach this. So we're looking for volume now. We're looking for volume. So what I'm going to do to find the volume of that composite shape is I need to find the volume of the triangular prism minus, okay, minus the volume of the cylinder, minus the volume of the cylinder. So that's going to be my plan. So let's go find the volume of those two shapes, and we'll just subtract them this time to get the volume of that composite shape. Okay, so volume of a triangular prism, let's start working on that first. I'm going to label it again so that we can tell what our work is if we need to go back and look at it. Okay, so volume is just area of the base times height. Volume is just area of the base times height. Okay, so the height of the prism is easy. The height of the prism, we can see it right there, is given to us, it's 14. But we need the area of the base, and that base is a triangle. That's also not too bad as far as we know. The formula for a triangle is 1/2 base times height. Now this base and height is talking about the base and height of the triangle. So I'm going to label that height of the triangle so we don't confuse ourselves with the 14. That's 1/2 the base of the triangle times the height of the triangle. Let's look closer at that triangle. I'm going to draw a cross section of it out here to help us with this. So it's an isosceles triangle because two sides are 5. So those sides are both 5 and 5. But we see that that base is 7.1. 7.1. Okay, so as far as plugging into that formula, 1/2 base times height of the triangle, the base we know is 7.1. So I'm going to drop that in. But what about the height of the triangle? We actually don't know that. If I take a look at my figure, if we drop an altitude from that isosceles triangle perpendicular to the base, that will be the height of the triangle. But what is that value? We don't know. I'm going to label it as X because we don't know. Well, the one thing I do know about isosceles triangles is that an altitude bisects the base. It splits it into 2 equal parts. So those split into 2 equal parts. So I can find that little part of that triangle. So now I'm focusing just on this little half triangle here. So let me pull that out. I'm looking at that little half triangle. That side is 5. We're trying to find the height of it. But that little half of the base will be half of 7.1, which is 3.55. Okay, so that's just half of 7.1. Half of 7.1 equals 3.55. That's where I got that. Okay, so if I know two sides of a right triangle, I can find the third side with Pythagorean theorem. So let's do that. I know that x squared plus 3.55 squared. Let me erase that so that that's a little bit clearer. We don't want any confusion there. 3.55 squared equals the radius squared. Remember, the radius is always the side opposite the right angle, so that's going to equal 5 squared. Okay, so to solve for that, x is just going to be the square root of 5 squared minus 3.55 squared. That way I can do that in one step in my calculator, and I get that x is approximately 3.52. We're only going to 2 decimal places today, so 3.52. So that's actually the height of my triangle. That's my x value, the height of that triangle, 3.52. So now I can drop that into my formula for the area of that triangular base. So 1/2 the base of the triangle times the height of the triangle that we just found. Okay. If I put that in my calculator, I get that the area of the base is approximately 12.5 centimeters squared. Okay, and now that I have area of the base and the height, I'm ready to find the volume of that triangular prism. So let's do that. The volume of that triangular prism, plugging all those numbers in. We said that's area of the base times height. So that's going to be area of the base times height. We said the area of the base, we just found it. It's 12.5. The height, we already knew it, was 14. We had it labeled over there on the side. And if we put that in our calculator, we get that the volume of the triangular prism is 175 centimeters squared, cubed, sorry. Okay, so this is volume now, so it's cubic units. If you think about it, we had area that was centimeters squared and height that was regular centimeters. So when we multiplied centimeters squared by regular centimeters, when you multiply like bases, you add exponents. So that was 2 plus 1, so it took us up to the third degree. And that's how we got centimeters cubed. So that's cool that our exponent rules work with our units as well. Now, I do want to label this volume. I'm going to put a subscript of TP on it for a triangular prism, so I remember which volume that is. And we're ready to move on to the next part of our, the next information that we need. We found the volume of our triangular prism, so now we need to find the volume of the cylinder. So I'm going to label it cylinder. And if I check my formula sheet, volume of a cylinder is pi r squared h. So taking a look at that, we were given that the radius of that cylinder is 1 unit, and the height of the cylinder we can see is the same as the height of the prism. So the height of the cylinder is going to be 14 centimeters as well. So let's plug those in. So our volume, we said, of the cylinder, I'll put a subscript of C there for volume of a cylinder. Okay, it's going to be pi r squared times our height. So plugging in a radius of 1 and a height of 14. 1 squared is 1, so that's just going to be pi times 14, or 14 pi. When we put that in our calculator, we get that that is approximately, make that a wavy equal sign because we've got some round off error here. We're going to call that 43.98 since we're going to 2 decimal places. 43.98 is the volume of the cylinder. Okay, so now we're ready to find the total volume of the composite figure. Our plan said volume of the triangular prism minus volume of the cylinder. So now that we have those two, we can just execute our plan. So the total volume of our composite figure, the total volume is going to equal the volume of the triangular prism, 175, minus the volume of the cylinder, 43.98. That was also cubic centimeters. Okay. And when we subtract that, we get that the total volume is 131.02 cubic centimeters. Again, volume is 3 dimensions, so it's cubic centimeters. We are working today. Now that we're at the end of the school year and our figures are getting more complicated, then our work takes a little bit longer. I don't want you to be intimidated by these composite figures. I want you to remember that you just look at them, break them down into their parts, and then we'll either add or subtract them. If we'll lay out our work and label our parts, we'll be able to walk ourselves through it. But whew, we are working up in here. Come with your questions to class, and we will see you soon.